Hello, everyone. My name is Andre Weigelt. I'm the Chief Technology Officer with ORIS Materials Intelligence, and I'm very pleased to be joined by my colleague Guillaume, who's going to introduce himself later. Today, we are talking about one of the most overlooked levers in sustainable infrastructure, construction materials, and how we've brought materials intelligence right into the heart of infrastructure design workflows using BIM and Autodesk Platform Services. I'm going to briefly set the scene with the industry context and our ORIS platform vision, and then finally hand over to my colleague Guillaume, who's going to take you into the technical implementation with our Autodesk integrations. At ORIS, we believe that sustainability starts well before construction begins, at decision-making stage, when planners, investors, and designers and engineers are selecting the right design and with that, the right materials to meet the project specification. ORIS is a mission-driven company based in France, in Lyon, and we are offering a digital SaaS platform supporting all stakeholders across different phases in infrastructure projects to build more sustainable and resilient infrastructure. We are currently deployed across major European and international infrastructure projects covering roads, highways, tunnels, bridges, and railways. So why are construction materials important to us, but more importantly to the industry? Let's have a close look into these numbers here. Overall, between 30 and 40% of materials are being used for linear infrastructure. But more significantly, they represent up to 60% of project cost and as much as 85% of carbon emissions. That represents a significant environmental impact concentrated in one phase of the process, which is often overlooked and under-optimized. Given the current challenges we are all seeing and facing, like climate change, social inequality, but also biodiversity crisis, this major environmental impact aspect should be really taken into consideration to build more responsibly and sustainably. And yet, despite this impact, construction materials are still selected using outdated methods like spreadsheets, PDF, or local knowledge, and don't follow a unified and aligned methodology. So from years of working with public and private infrastructure players, we've identified several common pain points in early stage infrastructure design. First, manual workflows still dominate. Engineers are spending hours finding, transcribing, or validating data between Excel, internal tools, GIS maps, or third-party data, which is really time-consuming and limits the variations for one single project. Second, each stakeholder in this process uses different methodologies and tools, which can create friction, needs sometimes rework, and leads to misalignment, and is very time-consuming as well. And third, even if the data exists, it's sometimes fragmented or outdated. Carbon factors might be missing. Performance data is not available to meet project specification. And all this can lead to a fragmented decision-making process. And this is exactly what we are solving with the ORIS platform. We digitize, connect, and contextualize the material decision layer for linear infrastructure projects. Working with major projects, as said, for public and private players, we've seen that by taking ORIS as a decision-making tool, we could optimize carbon emissions on the single projects by up to 50% compared to the base design, but also we decreased the amount of natural resources being reused by up to 80%, and with that, we could cut project price by up to 35%. Now, let's have a short look how this process on ORIS usually looks like. Let me walk you through the simplified four-step process, how we normally perform a carbon assessment, which we call material assessment on ORIS. First, the user needs to initialize the project by filling the form on the bottom left for the desired project. Here, the user can select on our map where the project location, the construction site is going to happen, can add some metadata like project name, project phase, but also the project type, be it a road, a highway, or a tunnel, for example. In the second step, the user needs to define its bill of quantity for the project. Here, the user can select from a rich set of available materials on ORIS in order to define the different layers of the project. They can choose from asphalt, cement, concrete, and aggregate layers, but many more materials are available on the project. All these materials come with the default CO2 value, which we provide in our database, but the user can always override and tweak this configuration if, for example, a local EPD was available. The user can also add additional operations or equipment to each material layer so that the assignment works very well for the project. In the third step, the user ORIS proposes the user default. In the third step, ORIS suggests potential sourcing locations to meet and source the required materials. Here, the user can, of course, define its own sourcing location, filter the preference, but also bring its own potential sourcing sites. Alternatively, a custom radius can be set for a particular material if no sourcing sites were available. If all these three steps were filled out, ORIS generates a dashboard where the user can assess the impact for each material layer, but also for the entire project assessment in terms of carbon, natural resources, and potential price impact. In order to really understand the impact, be it the transport, construction, or acquisition of materials, but also be able to generate, iterate, and compare different scenarios for different projects. So let me quickly have a look how we've built. So now let's have a quick look under the hood how we've built the initial version of the platform. Back in 2019, we started with a cloud-native approach, building our ORIS platform to make it scalable and extensible for future use cases. The core of our platform is the microservice backend, which is written in Java, Spring Boot, and Python. This microservice backend takes advantage of a comprehensive set of data sources and databases, be it climate data, CO2 databases for materials, but also a rich set of material database referencing more than 40,000 material suppliers. This backend is being exposed through an API gateway where all our services are available through RESTful API calls, which we integrate in the first place into our web-based interface written in TypeScript and React. That's how we started to build our platform a few years back, and we still, of course, operate this platform, but we always thought about making it extensible and integratable into third-party systems and the wider ecosystem in our industry. And that's exactly what we are going to look at in the next step, because since we can utilize the BIM models and BIM ecosystem even better, we've seen a huge potential to optimize the user experience on our platform. And now Guilherme will take you into the technical implementation, how we connected our ORIS platform into the BIM ecosystem.
Thank you, André. So I'm Guilherme de Montagnac, BIM advocate and software engineer in ORIS. And I'm happy to be here today with you to speak about the implementation of APS in ORIS. As André presented, before we integrated ORIS, before we integrated BIM, ORIS users faced a few significant challenges. For example, manual BOQ entry was time-consuming and error-prone, which really slowed down workflows. So it was two first steps of the material assessment. Extracting relevant data from models was also a very manual process, requiring a lot of time and effort. And when it came to optimization, users were typically only available to perform a single carbon footprint analysis without the ability to dive deeper into more detailed insights. These barriers really limited the ability to make sustainability a part of the design process early on. That is when we realized we need a smarter, more automated connection to BIM to truly unlock the platform's potential. So ORIS was initially integrated into Autodesk Civil 3D and AutoCAD through a net-based plugin. So ORIS was initially integrated into Autodesk Civil 3D and AutoCAD through a .NET-based plugin. As you can see on the top right, we added a new app into our stack. So the plugin, it was available directly on the Autodesk App Store, which made it easy for users to access. This integration allowed users to perform sustainable material assessment right within their design environment, for example, Civil 3D or AutoCAD. And because of that, it gained strong adoption among Autodesk users who were already familiar with those tools. Now, let's watch the use of the plugin through this video. So we are in Civil 3D. We are using corridors object. So here we are gathering all the 3D solids of the corridors and apply a material to each of them. And then we export it to ORIS to perform the carbon footprint assessment. So now we export it to ORIS. Here we are on the first step of the material assessment workflow. So it's a product location which is directly retrieved from the models. Then we get the bill of quantity automatically filled also with all the data from the drawing. Finally, we have just to do the third step, which is the research of suppliers. So we launch the calcul from ORIS. And we achieve the last part, which is the dashboard results of the carbon footprint of the model. So with the plugin, in 2 minutes, you can get the carbon footprint of the model of the drawings. But as we moved forward, some challenges started to arise. First off, the .NET architecture limited the solution to just Windows environment, so it couldn't reach a broader audience. Each Autodesk software needed its own separate plugin, which increased maintenance and made it harder to manage. On top of that, the release cycles for each plugin were independent and rigid, which meant we weren't always able to respond quickly to client needs. And lastly, it was thought to extend beyond Civil 3D and reach the wider BIM community. This limitation really highlighted the need for a more agile and centralized solution that could better meet our users' needs and scale effectively. So, to overcome the limitation of plugin-based workflow, we turned to Autodesk Platform Services, APS, unlocking the full potential of BIM through a unified, scalable web solution. So we made a significant shift. We made a significant shift from using native plugin to unified web solution application. This transition was made possible by Autodesk Platform Services. Instead of relying on multiple .NET plugins, we now have a single web application, which is highly integrated in our common platform. So no lack in user experience from tool to another. Some of the key benefits of this change include, first, we now have one unified interfaces, making it easier for users to work across different tools. It is compatible with various BIM formats, for example, IFC, DWG, DGN, Revit. So we no longer have to worry about maintaining a separate plugin for each Autodesk software. This shift also brought greater agility, meaning we can update features faster and respond more quickly to evolving client needs. With automation and efficiency built into the system, tasks like POQ extraction and data import are now streamlined. The results of all of that is fewer errors, faster analysis, and more flexibility to run multiple carbon optimization iterations. All in all, this web-based architecture not only enhances technical scalability, but also improves the user experience for everyone. So let's see now how this solution is embedded into ORIS with this short video. So here we are now in the viewer. We load the model. We have access to all the feature of the Autodesk viewer, especially to visualize and to manage elements. And then we are going to switch to the tab, especially for manage data for ORIS. So the iMapping detect automatically the property related to the material and volume property. And then we are going to apply or load a custom database which does the link between the material and ORIS material database with the type used in subtype of ORIS. And finally, we just select the material from the custom database, which material of the model to get a link between the two of them and be able to perform the carbon footprint assessment. Now it's finished. You have the possibility to create an assessment like the plugin with the 4 steps, or you can directly use what we call average distance sites. So it's a synthetic sites with a distance that you have to choose, for example, 50 kilometers. And in this case, you can directly get the carbon footprint of your project. So it's like in 1 minute, you get the carbon footprint. So for this implementation, we developed a micro front-end application called MFE APS using React and TypeScript. It integrates directly with APS to enable web-based 3D model viewing, interaction, and data extraction. On the bottom left, we can see that it is another app directly integrated into our architecture. If now we look at more in details, we can see that key APS APIs we use include authentication API for secure token, object storage service for file upload and bucket storage, which in our case, 1 bucket per client organization. Also, model derivative API to convert design file like Revit, DWG, IFC into a viewable format and extract metadata and geometry. We are currently also evaluating the design automation API for pre-processing files and the webhooks API for real-time translation updates. Sorry. On the backend, we use APS SDK to manage token, bucket creation, and file translation. And on the front end, we integrate the Autodesk viewer using a script tag and types for full TypeScript support. We have also some custom extension which enhance the viewer's interactivity, adding custom UI components, event listener, and project-specific logic. This architecture provides full control over the BIM data pipeline in a scalable, modern web stack. So I will quickly present you the global workflow of the data and what's happened from APS to ORIS. So if we look at the number 1, we first load a file in APS, so it will be loaded in the bucket with the model derivative APS. Then the file is translated into a web format. So if it's an IFC, a Revit, or DWG, it will be translated in the same format, which is a viewable format. After that, we get model metadata. So we retrieve from the model all the information we need, more in details, everything related to the volume and the material, and also the location. So the file load, the file data, and the extract of information is all related to APS. And then we switch to ORIS. So here we create the library of the user linked to ORIS database. So the user defines materials, and for each material, he assigns a usage, a type, a usage, and a subtype from ORIS database. And after that, he is able to do the match between the model material and the material from ORIS. So he does this match, and then it's more or less finished. He can fill the project details, for example, the name, the currency, the workspace if you want to work in a workspace, and the location if you want to change location. It's possible. And finally, he exports the project to ORIS, where all this data will be used to get the carbon footprint. And as an end of the cycle, we wanted to import back this data to close the cycle, but for now, it's not yet the case. So now I wanted to speak about a little bit code patterns. There is no groundbreaking revolution in the code itself. It's all about making the right architectural choices and leveraging APS effectively. So rather than diving into low details, I will walk you through the 3 focused examples that highlight practical integration patterns. Viewer customization through extension, data synchronization between BIM models and modern React frontend, and finally, how to embed real business logic into the 3D context provided by APS. Each example reflects real use case we have tackled and lesson we have learned. First example. In this example, we are showing a custom extension we built for the Autodesk viewer to better integrate ORIS into the user interface. Now, by default, Autodesk provides a toolbar that you can see in the center of the screen and some basic UI controls, but they are generic, visually limited, and not branded. So we customize it in the 3 key ways. First, we created a dedicated button placed right at the beginning of the toolbar using the control group system. So it's always visible and easy to access. Second, we apply advanced styling. That is to say, instead of relying on default button styles, we inject our own CSS into the page, defining exact dimension, ORIS colors, and even customizing the internal structure of the button for a clean layout. And finally, third, we added dynamic behavior. The button detects whether you are in a dev or prod or even local environment and redirects accordingly in a new tab. Compared to the default button, which is basic and static, this extension gives us full control over both the look and the logic aligned with our user journey. It is a small feature, but a good example of how APS extension let you deeply tailor the viewer experience to your application. Now I'm going to speak about the second example. So here you can see the results with the ORIS button on the left of the right of the screen, sorry, and the code on the left. Now I'm going to speak about the second example. Before getting into the technical details, let's start with the use case. So in ORIS, we need to extract and display large volumes of BIM data, sometimes thousands of objects, in a structured way for users to review materials, volumes, and perform carbon assessment. So as you can see on the right of the screen, it's an example of an extraction of metadata from an IFC, which only one corridors, and there is something like 1,500 objects just for one corridor. So if you're drawing with like 5 or 6 corridors, it will be something like 10,000. So there is a lot of data to manage. And APS provides a different way to access this data. You can fetch property individually with get properties, or use get build properties to retrieve them in batch. For performance reasons, we relied on get-build property, which is much better suited for large data sets. However, this API is a callback based, which makes it a bit clunky to use in modern React applications that prefer async await. So we wrapped it in a promise via a helper called getBuildPropertyAsync to make the integration smoother and easier to maintain. And once we get the data, we transform and structure it, for example, by extracting unique property names, and store it in a state using React hooks like useState and useEffect. This lets us feed the data into user interface components like tables or dashboard, with keeping everything responsive and modular. Yeah, so this slide was for just before that. So on the side, can you show the last slide, please? The next slide, please. Yes, this one. Thank you. So overall, we are combining efficient data extraction, modern asynchronous patterns, and clean React architecture to provide a performant and scalable experience. So on the left of the screen, you can see the part of the code to retrieve metadata. And on the right, you can see, for example, the number in this case of property, which is quite big of all the property of the model to manage it and to create the ORIS database. Now let's speak about the last example. This example look at a real business use case, and we are going to see how we had to go beyond the default behavior of APS to meet project needs. So by default, APS provide access to model geometry and metadata, as we have seen, but it doesn't handle business-specific logic like material assignment, organization workflow, or structural data persistence. In our case, we needed to build an interface that allow users to associate BIM elements with specific materials, manage this across multiple organizations, and support rich workflow like design export and change confirmations. To do this, we use a modern React stack with hook like useState and useEffect, and React query to handle API communication efficiently. We integrated with multiple external APIs to retrieve structured business data, in our case, material types, usage, subtypes, countries, organization, and use React query to manage caching and loading states. For data modeling, we relied on strong TypeScript interfaces, which help structure this business logic cleanly across the app. One key challenge was managing organization switching. If the user had unsaved changes, we needed to warn them before proceeding. So we implemented confirmation dialog and conditional logic to handle that smoothly. Finally, we built the mechanics to link BIM data to user-defined materials using tables and forms that group BIM object by property and export everything into a structured payload. So in the next slide, you can see the results of the match between the ORIS database and on the left, the BIM materials model. And so this goes beyond what APS offers out of the box and show how we can build real domain specific business logic on top of BIM data using modern front-end tools. And you have the possibility to develop and really imported your business logic into APS. So to warm up, integrated APS into the ORIS platform has had a strong impact across the board. First, from a business value standpoint, APS has streamlined our carbon footprint assessment by automating data workflows. That means less manual effort, fewer errors, and much faster, more reliable insights, which are the key to support sustainable decision making at scale. From a technical perspective, we have established a unified, scalable tech stack that is modern and future-proof. It supports a collaborative development workflow and allows for a much faster iterative release cycle, which is crucial for evolving business needs in comparison with the plugin, for example. On the user side, the integration is seamless within the existing ORIS platform, so it's fully embedded. User can import and map BIM data without needed expertise in LCA or BIM, making the process accessible, efficient, and intuitive. And finally, client feedback has been clear. They have experienced simplified project setup, smoother data transition, and faster workflows. Most importantly, the carbon assessment process now offers greater transparency, which builds trust and enables better decision making across the teams. In short, this integration is not just technical, it directly empowers our users and supports ORIS broader sustainability missions. Now, looking to the future, we are exploring the idea of an AI-powered BIM chatbot to enhance user assistance in BIM project. The chatbot will enable instant data retrieval, allowing users to quickly assess precise model information. It could offer interactive model interaction, integrate with the APS API, and 3D visualization tools, making it easier to navigate the model. Another key feature will be carbon footprint optimization assistance, where AI suggests best practice for reducing carbon emissions. Plus, it will automate routine tasks like report generation and data validation, improving efficiency and saving time. In short, the AI-powered chatbot will boost efficiency, accuracy, and user experience in BIM project, making them smarter and more streamlined. Thank you for your attention, and we are happy to take the question.